American V8 engines have powered everything from muscle cars to luxury sedans, earning legendary status for their rumble, power, and character. Yet, not every V8 lived up to the legend. Some went down in history as disasters that cost billions, left buyers stranded, and destroyed brand reputations. Take Cadillac's North Star, a billion-dollar project that promised 295 horsepower and German-rivaling luxury, only to fail with serious head gasket issues. Or Oldsmobile's 5.7-liter diesel, a gas engine conversion that self-destructed and sparked lawsuits costing GM hundreds of millions. Ford's 5.4-liter Triton turned spark plug swaps into $3,000 nightmares. Even Chrysler's lean burn tech failed, while GM's 8.1-liter Big Block grenaded itself with weak rods. These aren't just tales of bad engines. They're about broken promises, mistaken pride, and the real cost when car makers chase profits over trust. Today, we're diving deep into the most hated V8 failures in American automotive history. Hit that subscribe button right away and hype if you've loved this video so far. The infamous Cadillac North Star V8, 1993 to 2011. The first one on our list is the Cadillac North Star V8. This engine was meant to be GM's crown jewel, a 4.6-liter dual overhead cam, 32-valve aluminum beast pushing out 295 horsepower. GM invested over $1 billion in Cadillac's development to compete with BMW and Mercedes, equipping it with a powerful engine to transform its legacy. When the North Star launched in 1993, it looked like the future. The lightweight aluminum block kept things nimble, the advanced valve train delivered smooth and refined power, and critics raved about its performance. For the first time in decades, Cadillac had the tech to back up its luxury badge. But what sounded futuristic quickly became a nightmare. The engine boasted an advanced combustion chamber design, a unique cooling system, and even a bizarre limp home mode that let the car run without coolant in emergencies. It all sounded bold, advanced, and truly American. Then came the Achilles heel, the torque-to-yield head bolts. GM designed them to stretch for a perfect seal, but once stretched, they lost clamping strength. That meant coolant leaks, overheating, and eventually disastrous head gasket failures. And wouldn't you know it, this usually hit right after the warranty expired. The repair process was brutal. Aluminum heads warped, valve trains were destroyed, and fixing it required pulling the entire engine out from the bottom of the car. Cadillac buyers who invested $50 grand in prestige were humiliated by the North Star, which not only had mechanical failures but also eroded trust, causing many to abandon their cars. Even today, the name North Star drives used car buyers away. The small block Chevrolet 262, 1975 to 1977. When a small block Chevy shows up on the most hated list, you know things went really wrong. By the mid-1970s, America's muscle car glory days were gone. Oil embargoes, rising fuel prices, strict emissions laws, and pressure from Japanese imports had Detroit backed into a corner. Even Chevrolet's legendary small block couldn't escape the storm. The answer GM came up with was the 262 cubic inch V8, the smallest small block they ever made. On paper, it looked like an economy solution, but in reality, it was a gutless disappointment. With its tiny bore and short stroke, the 262 barely managed 110 horsepower at 3,600 RPM. To make matters worse, Buick's 231 cubic inch V6, yes, a six-cylinder, made the exact same horsepower. Owners quickly found out this engine wasn't just slow, it was flat-out uninspiring. Nobody wanted it. GM quietly pulled the plug after 1976, but leftover stock still trickled into a few unlucky 1977 Pontiac Venturas. The message was clear, this engine had no real place on the road. But GM didn't stop there, they doubled down on the mistake. Just a few years later, they released the 267 V8, which only squeezed out 10 more horsepower while being notoriously incompatible with other Chevy small block parts. For a company that built its reputation on simple, reliable, and interchangeable V8s, that was almost unforgivable. The 262 stands as proof that not every small block Chevy was a home run. Instead, it became a cautionary tale of how chasing fuel economy without real engineering vision could ruin even the most trusted name in American performance. The Dodge Red Ram 241 Hemi, 1953 to 1954. Putting a Hemi on the most hated list feels like breaking a sacred rule. But Dodge's first shot at the legendary name missed the mark. The Red Ram 241 Hemi debuted in 1953, following Chrysler's powerhouse Hemis by 2 years and DeSoto's by 1. On the surface, Dodge had all the right branding, a Hemi head design, a V8 badge, and the promise of performance. But under the hood, things told a different story. At just 241 cubic inches, the Red Ram was the smallest first-generation Hemi ever built. And while Hemis were supposed to scream performance, this one barely whispered. It made only 140 gross horsepower, which left Dodge owners wondering why they paid a premium for a so-called performance motor that couldn't outrun engines half its reputation. The problem was Dodge's decision to strip the Hemi concept of its muscle and turn it into a fuel sipper. With a low 7-to-1 compression ratio and a small 2-barrel carburetor, the 241 was tuned to burn cheap gas instead of delivering thrills. The result? An expensive-to-build engine that wasted the very thing that made a Hemi special: power. To Dodge's credit, they realized the Red Ram's shortcomings pretty quickly. Performance-oriented -1 series versions did show up in later, larger Red Rams. But by then, the damage was done. The first Red Ram carried the weight of disappointment, and the name didn't recover before Dodge moved on in 1957. For die-hard Mopar fans, the Red Ram remains a sore spot. The Ford 255 Windsor, 1980 to 1982. When smaller meant weaker, Ford gave us the 255 Windsor. In the late 70s, the auto industry was under pressure from new fuel economy standards, and Ford thought downsizing was the smartest play. So instead of sticking with the legendary 302 Windsor, they decided to shrink it down. By reducing the bore from 4 inches to 3.68 and slapping on smaller valves with restrictive oval ports, Ford basically strangled the life out of this engine before it even hit the streets. On the outside, the 255 looked almost identical to the 302. Pop the hood, and you'd think it was business as usual. Same block, same general look. The only real giveaway was the intake manifold, which had an open design with a lifter valley cover. Something that felt like Ford dusted off an old blueprint from the Y-block days. It was a weird throwback that didn't scream innovation, just compromise. The numbers tell the story: 122 horsepower. That's all the 255 Windsor could deliver in its best form. 122 horses in a V8. To put that into perspective, that's less power than a base 4-cylinder Mustang today. And yet Ford had the audacity to offer it as an option in the Fox body Mustang. Ford finally admitted defeat in 1982. After just 2 years, the 255 was canned. Ford brought back the 302, which went on to evolve into the iconic 5.0 we all know and love. But that short-lived 255 Windsor? It remains a black eye in Ford's small block history, remembered less as a solution and more as a cautionary tale of cutting too much in the name of fuel economy. The Oldsmobile diesel disaster, LF 95.7-liter V8, 1978 to 1985. When cost-cutting collides with diesel engineering, disaster is guaranteed. If the North Star felt like betrayal, the Oldsmobile LF 95.7-liter diesel V8 was pure fraud. In response to rising gas prices in the late 70s, GM tried to capitalize on the diesel trend, but opted for a cheap solution that failed dramatically. The shortcut was simple and stupid. GM took the Oldsmobile 350 small block gas engine and tried to turn it into a diesel. On the outside, it looked nearly identical, but inside, they made minor tweaks: stronger components, a new injection system, and lower compression. The one thing they didn't do? Reinforce the block to handle diesel's extreme cylinder pressures. That's where the destruction started. Diesels rely on compression ignition, which creates far higher pressures than gasoline engines ever see. GM's block simply couldn't handle it. Head bolts snapped, coolant mixed with oil, and engines self-destructed left and right. And the failures didn't stop there. The LF9 came with a laundry list of problems: unreliable injection pumps, constant water pump failures, and fuel systems that let in water, corroding precision parts. On top of that, these luxury sedans rattled like farm tractors. The diesel knock was so loud, some owners said passengers actually got headaches from the constant clatter. The fallout was massive. Class action lawsuits cost GM hundreds of millions, and thousands of cars had their diesel swapped for gasoline engines because the LF9 was simply unfixable. It wasn't just a failure, it was an embarrassment on a global scale. And the legacy? This single engine destroyed America's faith in passenger car diesels for more than 3 decades. While Europe moved forward with clean, efficient diesels, Americans only remembered noise, smoke, and blown engines. Ford's spark plug nightmare. 5.4-liter Triton V8, 1997 to 2008. A simple spark plug change on an F-150 can turn into a financial nightmare. What should cost just a couple $100s often balloons into a $3,000 repair. The reason? Those spark plugs have a nasty habit of falling off inside the cylinder heads. Instead of a quick tune-up, mechanics are forced to use special tools to fish out the broken pieces, turning a routine service into one of the most dreaded jobs in truck ownership. That's the infamous story of Ford's 5.4-liter Triton V8, an engine that made simple maintenance feel like Russian roulette and turned mechanics into specialists selling extraction kits. The headaches came in 2 ugly chapters. The first generation, 1997 to 2003, was notorious for spitting spark plugs straight out of the cylinder head while you were driving. Then the fixed 3-valve version, 2004 to 2008, went the opposite route. The plugs got stuck and snapped when you tried to remove them. The first round became known as the Great Spark Plug Escape. Ford's short thread design used only about 4 threads to hold each plug in place. That wasn't enough. Over time, combustion pressure pushed them loose until they literally shot out of the engine. Owners heard a loud pop, lost power instantly, and ended up stranded, usually with trashed aluminum threads that required costly head repairs. But the so-called solution was even worse. In 2004, Ford introduced long, 2-piece plugs that wouldn't blow out. Instead, they seized in place. Carbon built up around the extended shank, basically welding the plugs to the aluminum heads. When mechanics tried to swap them, the plugs cracked in half, leaving part of them stuck deep inside. That meant hours of drilling, extracting, and praying you didn't ruin the threads. The main point? You couldn't win. Wait too long and the plugs would seize. Change them on schedule and they'd snap. Shops started charging sky-high hazard rates for plug changes, and some refused the job altogether. At the root, it was engineering a conflict with reality. The aluminum heads and steel plugs corroded together, while Ford's designs ignored long-term serviceability. The Chevrolet Vega aluminum disaster, 2.3-liter 4-cylinder, 1971 to 1977. Wait a minute, a 4-cylinder? The Chevy Vega's failure planted the exact seeds that later doomed V8s like Cadillac's Northstar. Back in 1971, GM thought it was building the future. The Vega came with a lightweight, innovative 2.3-liter aluminum block that ditched traditional cast iron liners. Instead, GM used a high-silicon aluminum alloy, A390, that was supposed to be hard enough to resist wear on its own. In theory, it saved weight, cut costs, and matched what brands like Porsche were doing. But theory is one thing. GM's execution was another. Instead of rigorous testing, the design was rushed to market to battle the flood of compact imports, and the results were catastrophic. The first big problem was damage. With no iron liners, the aluminum cylinder walls wore quickly, especially during cold starts before oil could circulate. Engines began burning oil almost immediately, leaving blue smoke clouds everywhere they went. Then came the mismatched metals. GM paired that aluminum block with a cast iron head. Different expansion rates under heat meant warping, blown gaskets, and even more overheating. And once the engine overheated, the silicon literally burned out of the aluminum, leaving soft, weak spots that wore down faster. To make matters worse, the Vega's cooling system was criminally undersized, radiators barely bigger than a motorcycle's, with no coolant recovery system. Every drop lost made overheating inevitable, and once that started, the whole engine snowballed into failure. The Vega taught GM all the wrong lessons. Instead of learning how to properly engineer aluminum engines, they blamed the material itself and retreated into iron for decades. When they finally returned to aluminum with engines like the Northstar, they repeated the same sins: weak head bolt design, thermal expansion chaos, and cooling nightmares. GM sold over 2 million Vegas, and with them created 2 million bitter ex-customers who jumped to Japanese cars and never looked back. More than just a failed 4-cylinder, the Vega was a warning shot, and the mistakes made here haunted American V8s for years to come. GM's big block blunder, 8.1-liter Vortec V8, 2001 to 2009. Big power doesn't mean bulletproof. GM's 8.1-liter Vortec looked like the last great hurrah for old-school big block muscle. At 496 cubic inches, this thing should have been unstoppable, simple, tough, and ready to tow anything in sight. Instead, it went down as one of the most self-destructive V8s America ever built. On paper, it sounded perfect. GM pitched it as the big torque solution for heavy-duty trucks and commercial rigs. No fancy overhead cams, just a pushrod monster with old-school roots. With 340 horsepower and 455 pound-feet of torque, the 8.1 had the grunt to drag massive trailers and work all day long. For buyers who wanted raw pulling power, it seemed like the right tool for the job. But then came the disaster. Instead of forged steel connecting rods, GM went cheap with powder metal rods. That decision doomed the engine. In a small commuter motor, maybe fine. In a 496 cubic inch beast, absolute disaster. Around 100,000 miles, sometimes way sooner, those rods cracked, burst through the block, and left owners staring at an engine that was beyond saving. And the warning signs were loud. Even before the grenading rods, these motors developed piston slap, a harsh knocking when cold. That wasn't harmless noise. It meant sloppy tolerances, poor piston design, and an engine wearing itself out long before its time. Then there was the gas pump misery. Single-digit fuel economy wasn't unusual. This wasn't just because it was huge. GM stuck with outdated fuel management and inefficient chamber design. Competitors were modernizing, but GM left customers stuck with a guzzler. In the end, the 8.1-liter wasn't just a bad engine, it was the end of an era. Instead of going out with dignity, America's last big block bowed out with rod failures, piston slap, and gas bills that made owners regret every mile. The electronic disaster, Chrysler lean burn V8, 1976 to 1979. The next one is Chrysler's lean burn V8 system, which was meant to change everything: electronic engine control, better fuel economy, and cleaner emissions. In 1976, that sounded revolutionary, but the technology just wasn't ready. And this innovation became one of the most hated American V8 setups ever. The pitch was bold. Chrysler's system used a microprocessor and sensors to adjust spark timing with way more precision than any old-school distributor could manage. 8 different sensors fed it data: throttle, temperature, and more. When everything worked, the lean burn engine ran smoother and cleaner and used less gas. But that's where reality hit. The tiny computer sat right on top of the air cleaner, in the hottest, roughest, most vibration-heavy place in the car. No surprise. The circuits fried, the solder cracked, and the parts failed constantly. Add in a spaghetti mess of vacuum lines and sensors, and the system rarely worked right for long. Cars ran so rough they seemed broken, but diagnosing the issue required skills most shops didn't have. Many mechanics just ripped the system out, slapped on a carburetor and a standard ignition, and told owners to forget Chrysler's miracle tech. The reason it failed? Timing. The concept was ahead of its era, but the components weren't ready. 1970s electronics couldn't survive under the hood. It wasn't until the 1980s that engine computers finally became tough enough to work reliably. Chrysler just jumped too soon. In the end, lean burn went down as a cautionary tale. It promised the future but delivered headaches. Instead of saving Chrysler, it made their V8s some of the most frustrating American engines ever built. These 5 engines, Cadillac Northstar, Oldsmobile Diesel, Ford Triton, Chevrolet Vega, and Chrysler Lean Burn, stand as cautionary tales of what happens when cost-cutting and overconfidence replace sound engineering and customer care. The Northstar showed that technology means little without execution. The Oldsmobile Diesel proved shortcuts haunt brands for decades. The Triton revealed how a simple flaw can snowball into disaster. Beyond mechanical failure, these engines broke trust, drove customers to rivals, and inflicted financial pain. Their legacy isn't just failed machinery, it's the reminder that reliability and respect for customers must always come first. What's the worst American V8 engine of all time? Was it Cadillac's Northstar, Ford's spark plug nightmare, GM's diesel disaster, or Chrysler's lean burn mess? Share your pick in the comments and join the debate. If this breakdown of the most hated engines hit the mark, smash that subscribe button, tap the bell for future uploads, and drop a like to support the channel. More deep dives into automotive history and the machines that shaped it are coming soon. So stay tuned for the next chapter in the Hall of Fame and Shame.